it's recording. Okay, so so this is the course that is being run in NPTEL. This particular course will be a very introductory course to machine learning, but there is no such thing that these things are not important. One particular thing that has taken the center stage right now is deep learning, but machine learning preceded deep learning by, I don't know by how many years, many years maybe, some 20 odd years. So this is the course that will create the foundations for some advanced machine learning techniques in the future. So without talking much about the introduction, okay, first I'll introduce myself. I am Shomo. I am a PhD student at ISC Bangalore, and I work in the field of speech processing, so which is just one of the sub branches that machine learning has influenced a lot of things. So yeah, I'll share my slides, and if you have any questions, you can please speak up, because I won't be looking at the screen of Google Meet. So you speak up when you have any questions. It will be an introductory lecture, so it will be short, and you can ask me questions in between if you want. Okay, so starting the lecture would be, the first question is, what is machine learning? Since some of you, I mean most of you will be learning this term for the first time. So it's like yeah, so generally what we do is we have I mean, this is the normal pipeline of any machine learning system. Like, we will have a large amount of, I should have waited for maybe 5-10 more minutes, I guess. Yeah, I'll wait for 2-3 minutes more maybe, because once I start, then coming back to this window will be bad for all of us, I guess. So I'll wait for 2 minutes maybe. Okay, I'll get back. Okay, so yeah, so the problem of machine. Okay, so the general machine learning pipeline would be something like this. Like, you will have a large amount of data. What data is large data? That is a question in itself. But let's say we have a large amount of data, and we want to learn algorithms from that data. What do we mean by learning algorithms? We want to learn algorithms so that we want to map that data into some particular functions. For example, you look at a digit, and you want to classify it, and you want to classify it like a normal human being does. So the data in this case is your digit, and the algorithm is given a digit, what is the algorithm that will tell me that this is the number that is being written in that digit. So that is done iteratively, and so this allows the computers to find out patterns without telling it where to look. So for example, yeah, so for example, yeah, so what do I mean by without telling it where to look? For example, when you show this this is like everybody should be able to join without me giving the permission maybe from next time. Can I change that somewhere? No, I don't think I can change that. Okay, so yeah, so when given a digit, we are not telling the computer that look at the particular way 4 is being written, or look at the particular way there is a 9, there is a round at the bottom, and then there is a straight line after that. We are not telling the computer anything of that sort, but what we are saying is we are showing the computer a large number of 9s. Now, and we are telling that now that you have looked at such a large number of 9s, you should figure out that this is the way 9 is being written, so that when somebody else comes and shows you a 9, you are able to tell that this is the 9, that this is the digit 9. So this is what I mean by the term that without telling it what to look. Now, one important thing that is often ignored is the importance of data, and for that, if you are able to see the two diagrams that are there, for example, you have trained a machine learning model for recognizing numbers, and you have fed the, which is, I mean, this is like the easiest problem that you can find in machine learning, and you feed it to the system the numbers which are shown on the left, which is the 9, 8, 7 something, and you train your model on that, and you get a very good training accuracy, but you start testing on the numbers which are on the right. Okay, now this is quite possible, and for human beings we find it very simple to go from this 9 to the 9 on the right, 9 on the left to the 9 on the right is pretty simple for us, but if till date it has not been very easy for computers to solve this problem. This particular problem is actually solved. This is from two very famous data sets, but I mean, there can be more difficult problems, like for example a very simple classifier like dog cat classifier. Suppose you build a classifier and you want to you want it to predict whether the picture that you are seeing is that of a dog or that of a cat. Now when you are training your model, you have got images of dogs and cats which are all taken during daytime, but during testing you are giving it images which are same dogs and cats maybe, but they are all taken during night time. So you will see that the machine learning model won't be able to perform well in such cases, and this is the reason why somebody has a question.
Yes, Professor, can I talk to you? May I ask a question?
Yeah, you can ask, surely.
Yes, sir.
Yeah,
Because this is the discussion class, na, so I
yeah,
can ask the
yeah, you
class.
can ask. Yeah.
Yes, sir. I want to ask, sir,
Uh-huh.
one of the question was there
Hmm.
regarding, I'm trying to categorical features, sir. So categorical features means we want to find out the categories which we can identify, sir.
See, there are several sort of features. This is an assignment question, right?
Yes, yes,
Yes.
yes.
So the categorical questions or the categorical features are. So okay. So let me give you an example. For example, I am talking about today's temperature. Okay.
Yes,
So today's temperature can be several values. Like, I mean, you cannot say that. I mean, it is a real value in that sense, right? So it can be
yes,
26.1, 26.2, 26.3, and so on. And you can go up to number of decimal places also. So
yes,
that is a real value. So that is not a category. If you think of the term category, so that is not a category in the true sense of the term category. But let's say I am talking about what day of the week today is. So today is a Saturday. So if you see, there may be only 7 possible answers to that particular question, right? Which means that
okay.
every day is actually a category in that sense. So you
Okay, in
understand that
that sense, sir, what was the choice was the like a nationality of a person. So is it category? As per my opinion, the nationality of the person.
nationality of the person would be I mean, it will be a large number of there can be a large number of nations, but it is a category.
Okay, okay.
Okay, so
Thanks.
yeah.
Then what we should take the option, sir? Then type of mountains that can also be the categories.
Types of every type of a thing can be a category, but I mean,
Height of a person, right?
height of a person can't be category, right? It cannot be category because
Yeah.
there can be, it is a real value. So if you see that it is a real value, then it is obviously a category. If it can take only discrete values, then it sorry, if it is a real value, then it is not a categorical variable. If it takes only discrete values, then it's a categorical variable. Okay.
Oh, thank you, sir.
Yeah.
So can you explain me the difference between nominal and ordinal?
Nominal and ordinal, this is a question from the assignment, right? Again.
Yes, sir.
Yeah, so ordinal variable is like a categorical variable, except that you will have ordering between the different categories. Like I said, for example, you are talking about the grades that you receive in a particular subject. So in that A, B, C, D, E, if you, I mean, depending on your college, let's say A is the highest grade, B is the second, B follows after that, C, D, and so on. So there your grade systems, I'm not talking about CGP of 9, 10, and so on. I'm talking about the grades A, B, C, D. There your those particular things would be categorical variables, but you have a inherent ordering between them, that A is greater than B, B is greater than C, and so on. So they are called ordinal variables. Nominal variables,
Yes.
as far as I know, are the same as categorical variables. I'm
In
not.
that case, those are inherent features. You can say you can get not find the orders, right? So nominal
Nominal
while you
variables you won't.
ordinal you was depend the grade of the students of the college. So then it is the ordinal variable.
Then that is the ordinal variable. If, for
Yes.
example, the gender of a person would be a nominal variable or a category. I'm not actually sure about the difference between nominal and categorical. I think they're the same. But
We can say all ordinal values are categorical, but not all
or yeah,
categorical.
correct. That you can say. Yeah,
So
yeah.
in that grades option, we can select both of these, right?
I am not. I'm not hearing you properly. Can you come again?
So we can select both of these as the correct answer, right?
Uh,
For the grades for the questions.
which one? I did not. I don't have the question in front of me, so.
Okay, so they were asking about the grades A, B, C, D, E, F.
No, I'm giving the grades as an example. Suppose your
So
college gives a
let's say you
grades.
had these many options.
Huh? No, I'm talking about the grades. I talked about the grades as an example. Like, for example,
Yes.
I mean, grades you can talk about an example. In some sense, you can talk about the day of a week also as an example, like Monday, Tuesday, and so on. So that is also, I mean, you have an inherent ordering. You know that Tuesday comes after Monday, Wednesday comes after Tuesday. That is why you can talk about the ordering between those particular categorical variables also. So when the categorical variable allows you to have such an ordering between them, then you call them ordinal variables. Okay. So I talked about the grades just for an example. It's not like I
Sir,
yeah,
hello.
yeah, yeah.
So, what is the meaning of learn algorithm? Means we have to make a algorithm able to learn from data.
Correct. So, for example, the normal branch of computer science, or the main branch of computer science, what it does is you design an algorithm, right? That is the first thing that you learn as a computer scientist. You design an algorithm. It works on certain data and gives you certain output. Here the middle block is absent. Here you have data and you have output. You need to figure out the algorithm that generated that output.
Yes.
Okay. Yeah, so that is the essence of machine. That is the black box way of understanding what machine learning is. Okay, so I'll go forward. Yeah, so applications, I know that you might have seen this in multiple places. So the top leftmost application it's a very famous data set called MNIST. It's a digit classification data set. So it was solved I mean it has been looked at for decades now, and the middle one is the face recognition application of machine learning. The top right part is like it is something that Gmail does every day to your mailbox. Whenever you receive a mail, Gmail will look at the mail and try to understand whether it's a spam mail or not. And then coming down to the left, bottom left, it's a speech recognition task. Like if you know of Google Home or Siri or Alexa, so all these things, they are able to understand what you are telling, and that is primarily because they have a ASR engine, which is also known as automatic speech recognition engine, built into them, which is why whenever you speak, they are able to understand what you are trying to speak. The third, I mean the last one on the bottom right is stock market forecasting. I don't know whether this is used that much, but I just kept it because it is a time series forecasting sort of application. That is why I kept it. So yeah, so these are some applications. The first two are the face recognition and the image recognition or the digit recognition are computer vision tasks. The spam filter is a natural language processing task. The ASR or speech recognition is obviously a speech task, and finally the this forecasting thing is a time series task. So these are the applications. So now there are different types of machine learning, and I wanted to cover this because I saw that it has been covered in the week 1 of this lecture. So the first type is supervised machine learning. So it's a very simple thing, like given a set of examples and their labels, you learn a function to map from inputs to outputs. So for example, if you again see the image data set, you have a 5, 0, 4 and so on, and so those are the inputs. The 5, 0, 4, those figures are the inputs, and the outputs are the labels, the 5, 0, 4 and so on. And in supervised learning, what you try to do is you look at these examples. Yeah, you look at these examples and try to classify unknown image or unseen image into its corresponding class. So when you are doing this sort of thing, like you have an image and you want to classify it, or you want to, or for example, you have a dog cat classifier, you want to classify whether the image is that of a dog or that of a cat, you call these problems classification problems. Suppose you have, I mean, this is another very famous data set on the right, which is house prices prediction data set. So you have a house and you have certain features, like you have the area of the house, then you have the number of bedrooms in the house, then you have the location of the house, and depending on all these, you will try to predict the price of that particular house. So in such cases, the problem is known as regression. So since we talked about certain variables, I'll ask a question here, in house price prediction, what do you think would be a categorical variable? Can somebody answer this?
Nominal?
No, I'm talking about give an example to me of a categorical variable. I mean, you have to give a feature which can be a categorical variable. It can be nominal or ordinal, doesn't matter.
Area of the house.
Okay. Yeah, so somebody said area of the house. So why do you
It could be the
Number of
the
rooms.
place, like the
one
rural of the city.
please speak
Number
one.
of rooms.
Yeah, number of rooms is correct. Somebody said area of the house, right?
Yes.
So yeah, so why do you think area of the house is a categorical variable?
It is not categorical. It's a regression method value that it can be varying, maybe like 1,000 square feet or 1,500 square feet.
Yeah, so that way you are thinking like maybe from the practical point of view that okay, the area of the house is only 1,000, 1,200, 1,300 and so on. But it may not be like that always, right? I mean, you can have different area of the. I mean, area of the house is a real parameter. So
Right.
in that case, you can't say that it's a categorical variable.
Right.
Okay, yeah.
Yeah.
But the other answers, somebody told number of rooms, number of floors, all those will indeed be categorical variables, and some of them will indeed be again they might be ordinal variables also. Okay, so mm, right. Okay, so this is the first type of machine learning. This is I mean, I think in the first week only this type of learning was introduced in the lecture, and this is the almost I can say the easiest. I mean, apparently it's the easiest form of machine learning. So what are the other types of machine learning? One is unsupervised learning, which is like given a set of examples, you want to learn relation. Yeah,
Sir,
yeah, yeah,
so
yeah,
miss,
yeah,
sorry for the disturbance. Can
yeah.
you elaborate more on the classification, binary and multi-class, like
Binary and multi-class. Okay.
multi-class?
So for example, how can I say? See, binary classification is like, mm,
Has only two categorical variables.
yeah. So binary classification is like whether you have. Okay. So let me give this example. You have a,
Email,
yeah.
sorry, email classification is a
Exactly,
binary.
exactly. It's a spam or a non-spam classifier.
Yes, yes,
Correct.
yes.
Now, suppose if you see there, so yeah, since we're talking about email classes, email classification, if you look at your Gmail, whenever an email comes, Gmail classifies it based on different tabs. I think most of us have seen that, correct? Uh, so, so given a mail, how does Gmail understand whether it should go into primary, whether it should go into social, whether it should go into promotions, or whether it should go into updates? So that is not a binary classification, because there are no two ways to, I mean, there is no right and wrong. There might be, I mean, so one email can be any of the four classes, and that is the case when you have multiple classes. Okay, so that is the multi-class classification. Did I was I clear? I forgot who answered, who asked the question, but
Uh, and so on this. And what is multi-class classification?
yeah. So this
And
is,
so and binary. Can you give?
yeah. So for example, when an email comes to you, classifying it as spam or non-spam is binary classification. When email comes to you, classifying it as primary, promotions, social, or updates is multi-class classification, because there are no two classes in there. So when the number of ground truth classes increases to more than two, you call that to be this thing. You call that to be multi-class classification.
Okay,
Uh,
thank you, sir.
yeah. Okay. Okay, so yeah, so the next type of machine learning that I would like to talk about is unsupervised learning. So what is the supervision? What was the supervision here? The supervision was given a 5, you told the computer that this is a 5. Given a 0, you told the computer that this was a 0, so that when you see a next 0, you better label it as 0. Now sometimes you may not have such label data, right? You will, for example, somebody went and labeled all these some 60,000 training images in this data set and labeled them individually. All cases, for example, in many new cases where new applications of machine learning are coming up, you may not want or you may not hire people because you have to pay them. Once they annotate something for you, you have to pay them. So some people won't like to pay something that I mean, just for annotation they won't want to pay a lot of money. So for that, what they do is they do something called unsupervised learning. um, yeah, unsupervised learning, which is like they have a set of different fruits, and they will pass it through the model, and the model won't be able to classify them as different. I mean, the model won't be able to know that okay, these are the fruits that are these are the 2 3 or 4 type of fruits that was given to me, but depending on some similarity between the fruits, they will be able to cluster them. So unsupervised learning can be thought of as clustering. Okay, so so here I have two pictures, one on the left and one on the right. Can somebody answer which one is unsupervised and which one is supervised learning, and why?
Right side,
uh,
right side or
right side is unsupervised or supervised?
unsupervised.
Unsupervised.
Yeah,
Unsupervised, sir.
yeah, why? Can somebody?
Unsupervised because the names are not given us, the categories are
Because
not
we are
given.
using clustering.
Group of fruits, sir.
Correct, correct,
We
correct,
have not labeled the data.
correct,
Label
correct.
data is not there.
Correct. So that is what is known as unsupervised learning. But here there is a fundamental problem in the sense that you can cluster, but you won't know that the top four fruits are apples, the last two are bananas, the middle two are I don't know, peaches or something maybe. So yeah, so you won't know this what they are, right? You won't be able to label them. So for that, what we need to do is we need to go to something known as semi-supervised learning. So semi-supervised learning is so if you look at the picture that is given here, it's a bit advanced. So let's think of that in this way. Like we have a labeled image of a dog. So the top image that is above the dotted line is actually an image of a dog which is labeled to you. So this is the case when you have, for example, in here you had many fruits, let's say, and you don't have the labels for anything, for any of the fruits for unsupervised learning. But for semi-supervised learning, what you can do is you can have this sort of a some apples are labeled, some bananas are labeled, and some peaches are labeled. Let's say you have that situation. Okay, so then what you can do, for example, in this case you have two images of dog. One is labeled, the other is not labeled. The bottom one is not labeled, the top one is labeled. So you take this, you take all the labeled images and you pass them through a model and you try to classify them as dog or cat. Okay, so after classifying them as dog or cat and after the small number of labeled examples that you have taken, after you have built up that classifier, what you do is you take that unlabeled image and you pass it through the same classifier. And so a very naive way of doing this would be you take the representation, I mean that image, you pass it through the model will give you some output, some representation of the image. That representation you check with all the labeled examples that you already have, and the closest one that you find, you label that unlabeled image as that label. Okay, so for example, if you have an unlabeled image here and you pass it through the model and the model says that it's a dog, it's a dog classifier, it's a dog. If you see that it's the model is predicting it as a dog, then you label that particular image as dog, and again you retrain the model with this dog which you just predicted from the model as your pseudo label. So you generate some sort of a pseudo label in this case, so that your unlabeled image is not just it's not just clustered, but it's also classified according to a particular label by semi-supervised learning. This is what is known as semi-supervised learning. This is a bit advanced. I don't think this will be taught in this course anyway. But I just wanted to show that there is something called self-supervised learning also, but I'm not going into that. Okay, so finally the other thing that this I know very little of because I don't work in this domain, but there is something called reinforcement learning. The idea is you have an environment, so this is largely how we learn in our lifetimes. Like we do something, when we are young we do something, we get hurt or our parents scold us, and then we learn that we shouldn't do that because we are getting hurt. So what is that hurt? That hurt is nothing but a reward function that is coming to us, and when we are doing something good, somebody comes and rewards us. So that is the reward function that we are doing. So at a given a particular point of time, the actions that we take will either help us or it will deter us. So if it helps us, then it's a positive reward, and we will know that okay, from whenever I am coming into this state, I will take that action and I won't take the other action because that will not give me any reward. So that is in essence a very brief overview of reinforcement learning. There is much more to this, but yeah, so I'll keep it at that. So these are the different types of machine learning that that I think was taught to also in this week, and I just brushed upon them.
Soumya sir,
Yeah.
give one more example for reinforcement learning, please.
Okay, so one more example would be like you know about self-driving cars, right? As I said, I don't work in this field, so I'm not very aware of the latest these things. But one thing would be in self-driving cars, when you are when they are being trained, they are put into different environments. Environment means simulated environment might be, and for example when they are very close to a car, and so the position of the car is the state as I talked about. So there are three things here if you can see. The first thing is you are the AI, which is a self-driving car, the state, reward and the action. So the state at one particular time might be you are a self-driving car and you are very close to that to the car in front of you. Okay, and the action that you might take, the two possible actions that you might take is you might accelerate or you might brake and stop. So if you are accelerating at that point of time, that means you will go and hit the car. In that case, the environment, which is the environment is the world in essence. So the world will say that okay, since you have hit a car, which means you are getting a negative reward, which is -1. If you are braking at that particular point and stopping, which means you are not hitting the car, that means you are getting a +1 reward. So with time, if you run these experiments multiple number of times iteratively, with time the AI system will itself learn to understand that okay, to maximize my reward, when I am very close to a car, I should not accelerate, I should brake, because that way my reward will increase. Okay, was I clear?
Yes, sir.
Sir, hello, sir.
Yeah.
Sir, how is this reinforcement learning different from the unsupervised learning?
Because in unsupervised learning you are not given that reward, right? In unsupervised learning you are just given a set of examples and you want to cluster them and you want to find out similarities between them. In reinforcement learning you are explicitly told that since you have hit a car, now you will get a -1 reward. If you are not hitting a car, you will get a +1 reward. Okay.
Okay.
Yeah, so the rest of the lecture I would mostly talk about supervised learning because that is what was taught in the week. So the general pipeline is, for example, you are trying to output whether the input picture is a car or not a car. So you have an input, you do some feature extraction, you do some classification, and you get the output as car or not a car. So basically it's just design and classify to predict the correct class for classification or predict values for regression. This is pretty simple. And so coming to the pitfalls of pitfalls of machine learning, the two major problems that we face is underfitting and overfitting. So what is underfitting? Underfitting means model does not perform well on the training data itself. So whatever data you are training your model on, your model is not being able to classify or predict the values of your training data itself. So you can lose you will obviously not be able to perform well on unseen data. That's the first thing, which is known as underfitting. And underfitting is also known as a high bias system. Yeah. So underfitting is also known as a high bias system, and overfitting is something which means that your model is trained extremely well on the training data, but it is not trained well on the test data. Which means that your model is, so you are not being able to generalize properly. So this problem solve underfitting. So in order to solve underfitting, since your model is not being trained on the training data itself, you need to make the model stronger, and by stronger I means you increase the number of parameters in the model, and however the stronger model will lead to overfitting. So there is a fundamental problem of the underfitting and overfitting trade-off, which is also known as the bias variance trade-off. This term you will find at many places in all machine learning books. You will find what is the bias variance trade-off. I just wanted to tell you that this is something that I as a researcher have faced n number of times. Okay, so this is a problem that is there everywhere. Like in this figure, if you see, it's very easy to show
Sir,
that.
what
Yeah.
excuse sir,
Yeah.
what is the relation in underfitting, overfitting, and biasing and variance?
So underfitting means high bias, and overfitting means high variance. So I don't have the pictures here, and I don't
Sir,
have.
underfitting means high bias, right, sir?
Yeah, underfitting means high bias, and overfitting means high variance. Okay, so
How do you define bias, sir?
okay, bias. So I don't have this thing for that.
State the bias in words.
yeah, so the bias is basically, so how can I say this?
It is an error, can I say?
It's of course an error. It's an error in the sense that so I basically why it is called bias in that sense is, I mean, bias is a very different sort of a different term in our mind, but so why it is called bias is not very, I mean, we are not very sure about it, but the major reason why, I mean, bias means you are not being able to train on the training data itself. You are biased in the training data itself, which is why I think it's called bias. Okay.
And to remove the underfitting problem, we need to increase number of columns, right?
Number of columns
Columns we need
means,
to increase.
columns means
Features.
number of, if you are
Features.
underfitting, then you should create number of features, or
And
effectively that for
Sir,
and and,
underfitting
and
means
over, excuse
variance
me.
is high or low, sir? With
just a minute,
underfitting.
somebody else was asking, so let him complete first, then I'll come back to you. Yeah.
Okay.
And sir, overfitting is if you are increasing more, if you have more number of features, then it creates a problem of overfitting, right?
Overfitting, right? So if you see, if you consider like you have to fit a straight, you have to, we have all gone through that curve fitting exercise, right? Hello.
Yes,
Yeah,
sir.
yeah, so we have all gone through that curve fitting exercise. So if you consider like your curve is somewhere else, so so it's like so you have certain set of points, but your line is not passing through them, it is passing through somewhere out, I mean they are not even touching any of the points, let's say, or not even passing through the not even passing through the region of the points, it's somewhere else. In that case you call that to be a biased estimate, which is why which means that irrespective of whatever data points you give, I mean since you are, yeah, so I can say it in this way. So if since you are since you have a training data, you would want to say that, okay, given a training data, if my test point is very close to the training data, I should be able to predict it correctly. Okay. But if your system is biased, which means it is not trained on the training data itself, then if you are even given a point which is very close to the training data, you will not be able to predict it correctly, and which is why it is different from what you have actually shown it, and hence it is called bias. Okay. And variance is, you are if you are doing curve fitting, then if your curve fits all the points perfectly, then that is overfitting. Your model is not generalizable, and it will not perform well on the test data. Okay. So somebody is joining now. Okay. Okay. Was I clear? Somebody else was asking a question.
Sir, underfitting means low variance or high variance, sir?
Yeah, if you see here in this diagram, what do you think underfitting means?
Underfitting is in the first column, no, sir?
Yeah, so what is that, low variance or high variance?
Low variance, sir.
Low variance, correct. So and overfitting will be a high variance. So there, so that is what. So the dotted line that you see is the sweet spot, that you have the lowest generalization error. You have a low variance as well as a low bias. But this point is very easy to draw in diagrams. In practice, it is very difficult to achieve. So this is something that I wanted to show, because this is something you will face if you go on to do advanced machine learning. This is a problem that you will face everywhere. Okay, so this is done. Okay, so after that, so what is the solution to this? One solution is to create a validation set. So this is only a partial solution. What you do is you test your trained model on the validation set before testing on the actual test set. And so there are different methods of validation: k-fold cross validation, leave one sample out validation, etc. So some researchers keep a held out set also, but it is not used so frequently nowadays. Okay, so yeah, so finally I have two slides on metrics. So yeah, I have two slides on metrics. So
Somesh sir,
yeah,
can you switch to previous slide, please?
okay, yeah.
What is the difference between this k-fold and
Leave.
validation and all?
Okay, so k-fold cross validation is, let's say you have 100 training examples and you want to do 10-fold cross validation. K is an integer here, so let's say k is equal to 10, which means that you will divide your entire training data into 10 different 10 different these things 10 different groups. Every run you will take 9 of the groups for training and you will take the 10th group for test for validation. Okay, likewise you
Yeah.
will. Hello. Yeah, if you are not yeah, so you have 10 so you have kept 10 examples for validation and you will train on the 90 examples for training, train on the 90 examples. Similarly you will do this 10 times, at each group of 10 you will take once and you will train your model, and finally the model predictions you will take an average of all those. So that is the k-fold cross validation approach. Mostly because of the large size of data, this is also not done now. What people do is very simple, like they take the training data, they keep 80% for training, 20% for validation and leave it at that. So k-fold
So
cross
validation is done for to check the, you can say, performance of the system.
validation is done to check the performance of the system means I mean, it is done for a number of reasons. It is done so that so if you don't have validation, then what you will do is there will be a number of parameters in your model. So you will change those parameters and get the best on the training accuracy. But then you will see that you have overfit on the training data, and hence you would
So that means performance we are checking, na sir? That means.
performance your performance not exactly, you would want to tune the parameters of the model depending on the validation set. That is the essential reason why see if you look at this graph, then at you during training you won't have access to the test data. Okay, so what you will need to do is your model will have a number of parameters, for example number of features that you want to take. So how will you choose the number of features? As you increase the number of features, your training accuracy will go on increasing, but you won't know whether your model is overfit of the test data or whether it is a good fit. So so with which data set will you be able to decide the number of features that you are taking? So for that we set out a part of the training set as a validation set, and depending on the performance of our model on that validation set, we decide on the parameters in our particular model. And we hope that finally, since our model is performing well on the
That
training
means
data.
we are evaluating the performance and based on that we will change the
Correct,
value.
correct.
Oh.
Yes, yes.
One question: how we measure this bias and variance?
Bias and variance will come from the accuracy. So bias or the loss. So training loss will give you an indication of. So if your training loss, for example, goes down to, I mean, training accuracy, for example, goes up to 98%, but your validation accuracy is, let's say, 60%. It means that you have gone to a high variance position.
Right.
And if your training accuracy is not increasing at all, which means that your model is not being able to train on the training data itself, which means you are at the high bias zone. Okay.
So you are saying to run the same model on multiple training sets and maybe
No,
use
no,
like
no, 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 not multiple training sets. You will have a single training set. Let's say the test set is not given to you. So what you do is you train on the single training set. You set out. Let's say you have 1,000 such training points. You leave 200 training points aside. You don't train on the 200 training points. You test on the 800 training points, and you check the training accuracy on those 800 training points. Okay. The remaining 200 training points you don't train on, but you test on that, and you see what is the accuracy of that. If these two accuracies start to match, you mean that you can assume that your model is performing well on data which you have not seen, which it has not been trained on. So you can hope that once the testing data comes, it will perform well on that as well.
Okay. And this 80/20 is more of a generic rule, right? Like
It's
Pareto or something like that.
it's a generic rule. People use that. Some people use 90-10.
Okay.
So some people use 93-7. So there are different such techniques. So there is no one way to doing this. So you can have many different methods. Okay. Okay. So yeah. So finally coming to metrics. So again I would ask a question here. So on the left side you have a dog-cat classifier, and on the right side you have a benign and a malignant tumor classifier. So do you think accuracy is a good metric in both of these cases? If not, in which case it is not? Can somebody answer?
Would not help, sir. Yeah,
Huh? Could not
because
hear? Okay.
would not help because we are going to classify the things either yes or no,
Yes.
whether the tumor is malignant or not malignant.
Huh.
So if the accuracy would not help here because the accuracy will is 70% even though, so it will not we cannot infer that whether the tumor is malignant or benign. So I think it is meaningless to give the accuracy.
Why do you think it is meaningless to give the accuracy? Can you, I mean, the second last sentence. So why would you not know whether a tumor is malignant or benign in this case?
Actually, we are categorizing the things, the yes or no type of question we want.
Okay.
So accuracy will not help here. We want a concrete answer whether it is a tumor is benign or whether a tumor is malignant.
No, suppose you have a data set which has a large number of benign tumors, and let's say you have a data set of 1000 tumors, out of which let's say 990 are benign and 10 are malignant. So in this case you would be able to correctly classify, right, whether once another picture is given to you, your classifier will be able to classify, okay, this is a benign tumor and this is a malignant tumor. Do you think accuracy will be a proper would be a proper this thing, a proper metric in this case? I mean, I did not understand your point where you said we won't know that it is a benign or malignant. I mean, if we are classifying it to be a benign or a malignant, we will finally know that it is a benign tumor or a malignant tumor, right?
Because it doesn't take account of false positive and false negative.
Yes. Okay. So let me give you an example. Like this is like, okay. So let us consider as the last one, what I said, like we consider a case where out of 1000 samples 10 cases are of malignant tumor and rest are all benign. So malignant tumor thankfully are much less in number than benign tumors, and we have 10 cases. Now I have a classifier which predicts all tumors as benign tumor. So in this case, what is the accuracy? Can somebody say? All of the samples are classified as benign tumor.
90% accuracy.
90% accuracy. Any other answer?
1%, sir. It is 10 by 1000.
It is 10 by 1000. Okay. So let's see. Okay, let us work this out. So we have 1000 samples. Okay, and 10 cases are of malignant tumor, rest are all benign. So there are 990 benign tumors. Okay, and there are 1000 such samples. So what is so what is the accuracy now? So have you guys have gone through that false positive, true positive, false negative? Yeah. So
Yes.
what are the true positives in this case? I mean, positive means when a malignant tumor is given, you are classifying it as malignant because that is what you are interested about. So what is the true positive rate in this case?
99%.
Yeah, 99%.
How many are positive? My positivity is
Only 10 samples are positive.
and how many of them I am predicting as positive? See my
990.
See, my classifier is predicting all of them as benign. Okay, 10 cases are malignant and all of them are classified as benign. So what is the number of true positives?
Positive 10. False positive 10.
No, I am talking about true positive. What is the number of true positives in this case?
0.
Yeah,
Zero.
0. correct? So that is 0. What is the number of true negatives in this case?
N.
Huh?
990.
990. What is the number of false positives in this case?
0.
0.
0.
I mean, I see a lot of confusion in this case. Maybe I should have created a graph of something, maybe. Okay.
Like to start with, you say there are 10 positives, or you said only one positive.
No, there are 10 cases are of malignant tumor, rest all are benign.
Okay.
10 cases are malignant, okay?
Okay.
Somebody is joining. Yeah, so there are 10 positive cases and 990 negative cases, and I am telling all of them to be negative. So in this case, if you calculate the accuracy, that will come out to 99%, because my true positive is 0, true negative is 990, false positive is 0, false negative is 10. So it will be 990 by 1000, which comes up to 99%. So basically you will have a classifier which will be 99% accurate. But
Soumya sir,
yeah,
how false positive is 0? Can you please explain?
yeah, false positive is 0 because let's say your classifier is trying to predict whether a tumor is malignant or not. So that is the reason for which a classifier is built. So for the classifier, when so the classifier is not predicting anything as positive. So it is predicting everything as negative. So that is why your false positive also would be 0, because you are not predicting anything as positive. False positive is 0 is when you are predicting something as positive but it was actually negative.
Okay, okay.
Okay, in this
Got it.
case you are not predicting anything as positive, hence it becomes false positive 0, true positive also becomes 0. But your accuracy is 99%, so you will have you will be very happy that my classifier is 99% accurate. But this is one perfect example where you have prepared a classifier for trying to find out the malignant tumor, because that is what people will be interested about, but you are not being able to classify any of them. Your classification rate is 0 in this case, but your accuracy is 99%. So for that reason, we have something called precision, we have something called recall. I am not going into the formulas for them. You will have them in the lecture notes. And so precision, recall, and that harmonic mean is known as F1 score. So these sort of metrics are there. So this I just wanted to show because I wanted to let you guys know that apart from accuracy, there are many other such metrics which help us in these sort of classification problems. Okay, so yeah, so that will be all. So if you have any questions, you can ask, otherwise I'll close.
Soumya sir, could
Yeah.
you share this PDF with us?
This video will be shared, I guess, and the actually we don't have the this thing to share with the PDF with you guys directly. We will share it with the NPTEL people. They will put it up. Okay.
Please provide this PDF because it is useful to understand the basic concepts.
Okay, I will do that. I'll do that.
And
Yeah.
secondly, sir, we want a recording of this session also.
This YouTube link of this will be provided.
Okay, so other than precision and recall, is there any other metrics also which we can go?
There are other
which will help us
metrics.
with?
There are
Which
other
will help.
metrics like there is something called correlation score, correlation coefficient. There are different metrics depending on the problems, but I chose the metric because these are very simple. And for the first course in machine learning, these would be sufficient for you to go through this course.
Okay, thank you, sir. And
Yeah.
Sir, will this session be happening again or something?
Yeah, next Saturday again I will take another session. But this session yeah.
Actually, there is another session going on, and the timings are being clashed.
For this course.
Not for this course, actually for a different course.
Okay, I can't do anything with that because I can't change the course timings once the NPTEL has confirmed it with me actually. I'm sorry.
and so,
Oh, sir,
sir,
actually,
Yeah.
I got a message from the same domain,
Hmm.
IIT Bombay or IIT Mumbai, that we have a session schedule on Monday also, 6 to 7. Is it?
Monday, I
yes, sir,
think.
there
Yes.
are multiple timings.
There are actually 4 TAs. So 4 of us will be taking. One is on Friday, I know. One is today, mine is today. Monday there is somebody, I think from IIT Kanpur. IIT Bombay, I'm not, I mean, he had initially taken another this thing, another session. I'm not sure what his present timings are. There will be 4 such sessions in every week.
So could
And
you ask to share all the core links with us in one mail so that we can save that mail and we can go to
I think
particular day on that time?
NPTL has already shared it with all of you. I mean, that's what
They are
we.
so they are sharing with us the links, but we there are so many mails are coming and we are not able to classify that on day which mail we have to join. So in one mail, if it is written that okay on Friday on this timing this link will work, then we can directly save that mail and we can go
Yeah,
to
you
that
see,
link.
we were given some slots to fill up, and we filled up the slots, and we gave the links there itself. So that they said that they will do such things. I will mail them, maybe that's the only thing that I can do. I will mail them saying that this is the problems that you guys are having. So I will mail them, definitely I'll mail them.
Okay, sir. Thank you so much.
Yeah. Okay.
Sir, do
Yeah.
we will we receive this PDF?
This
When will we receive?
PDF, I will upload it to some place. I don't know whether NPTL will make it available to you. I hope they will do. The YouTube link will definitely be available. And
Sir, please, sir, please made it available. And
uh,
sir,
yeah,
one more thing that is unsupervised learning.
yeah.
We discussed that we have the asset of apples, oranges, and
Hmm.
these things. Okay, so
Hmm.
we are classifying according to their similarity in the different clusters or in different groups.
Yeah.
But sir, we are not able to label it. So that's why said that the semi-supervised learning is a nice way to go
Yes.
with, right?
Yes. Yes.
But then, is there any way to overcome this problem in the unsupervised learning? This one in the right side, which
See,
is mentioned on the right
unsupervised
side.
learning, the major thing is you will understand that okay, these data points are corresponding to the same class, these data points are corresponding to the another class. But you won't, nobody will come and tell you that okay, these are the image, these are apples, these are bananas, these are peaches, and so on. That knowledge not being given in itself is the essence of unsupervised learning. That is why unsupervised learning slowly became, I mean, it is still being used, but slowly it came up to semi supervised learning, because that, I mean, the thing that you just told, that is the precise reason for which unsupervised learning was discovered in the first place, because I don't want to label anything. I don't want the labels also. I just want similarities of objects to be important.
Sir, how it
Okay.
will work on the test set then?
Yeah, so the test set for this won't be there. I mean, unsupervised learning will be like so. So if you will be taught clustering after, I think, in this course itself. So when you will be taught clustering, you will see that there is no test set as such in clustering. There is, I mean, there will be no test set, or yeah. So one way which you can think of testing this is like, you have label data. Okay, am I still audible?
Sir,
Hello?
you're audible.
Yeah, yeah,
You're
yeah.
audible.
Yeah, so one way you can think of this is like, you have the label data. For example, the left side, you have the apples, but you don't use those annotations which are given. You don't use the labels of those particular, in the training data, you don't use that. Okay, you train it, you train your unsupervised clustering, unsupervised learning or clustering algorithm. The clustering algorithm should give you the oranges, or oranges, apples, whatever, bananas, whatever. They will give you different clusters of it. Now you take the test data, and in the test data you knew the labels. So you put a apple into the clustering algorithm that you just trained, and see whether it is being clustered along with the apples on the training data itself. If it is clustered with the apples of the training data, you can say that your clustering algorithm is working well. If it is not, then it is not performing well enough. That is one indirect way of testing these algorithms, but generally for unsupervised learning you don't have test accuracy reported.
Sir, you just discussed one more slide that is cat and dog like
Yeah,
slide.
yeah,
Can you move on to that, please?
yeah.
Here, sir, just now the Google has launched one project. The black people like African people, it is showing like these are the that monkey, gorilla monkey is type. So
Hmm.
that is again a kind of, we can say, error in the model. how one could overcome such kind
Yeah,
of
so
problem?
this problem that you just said is something that is actually being researched very what should I say, aggressively in the machine learning world. Like machine learning models have an inherent bias in them, and that bias is largely because of the data sets that we feed them into. So that is why I talked about data in the first slide itself. So importance of data is of paramount importance in machine learning. So if your data itself is biased, for example, you told one example, I can tell you another example. Like if you have a lady doctor and you want to classify whether a person is a doctor or not a doctor, just looking at I mean, even if the doctor is wearing stethoscope and wearing a coat and everything, just because it is a lady, it will not classify it as a doctor. It will classify it as something else, not a doctor. So that is the inherent bias that we have. So this is known as bias considerations, fairness, ethics, and all those things are coming up in AI. Yeah, those things are a problem, and those things we are still searching for solutions to those problems. It is not yet solved. Okay, any more questions?
Thank you so much, sir.
Yeah.
So on next Saturday,
Next
we will
Saturday
meet,
again
right?
4 to 5 I will take this class.
Okay, sir. On the
Every
same link.
same link. Every Saturday 4 to 5. I mean, I don't know why people are joining now, but anyway. Every day, every Saturday 4 to 5 I will be taking this class.
In assignments, I find that there are many difficult questions like to calculate eigenvalues, eigenvectors, probability like questions are there. So
That
we
is
will
in
cover that sort
uh,
of questions also in the session
that I didn't have a
because
plan, but if you guys want that, then that will be in one class itself. I mean, we won't go into week 2, week 3. I mean, I had planned on week 2 next day, but if you want, I mean, if many of you want, then uh, I don't know whether, I mean, since it is only 8 weeks and 8 week lectures are there, I don't know whether we can spend 1 week just on those particular things.
it would
Uh,
help us to solve the assignments given.
Assignment is week 1, right? Week
Hmm.
1 you don't have those eigenvalues thing, I guess. I
On
mean,
week zero, in week zero we do have that probabilities and eigenvector values and
okay,
eigenvector.
okay. So, okay, let me talk with the other people, other TAs in my class also, and who are taking the same class. I'm not sure whether we'll be able to cover, because I mean, one thing which I can assure you, that in the coming lectures, I don't know what I will cover in the coming lectures, but if I use any sort of algorithms or any sort of um, anything which requires you to know linear algebra or probability, I will cover those prerequisites in the lecture itself, and then I will go on and talk about the problem after that. So let me see. I'll figure something out maybe, because for those questions I will need to have a tab also, which I don't have. So I will by next Saturday I will figure something out, and next Saturday I'll see if I can do something.
So you are addressing from
So,
IIT Mumbai or IIT Kharagpur?
What I am?
You are addressing these sessions from
No, I am a student at ISC Bangalore, so I'm doing it from ISC Bangalore, from my hostel room at ISC Bangalore.
okay, okay, thank you.
Yeah.
sir, can we get the recording of this?
Recording you will get. Recording you will get.
So, where we will receive the recording?
That I don't know. It will be. I will give a YouTube link to the NPTEL guys, and the NPTEL guys will upload it to some place from where you can maybe this thing, where from where you can take, from where you can see basically. I think it will be uploaded there.
So, how will we receive the link of that YouTube channel? Uh,
YouTube channel link. Okay, I'll put that. Right now I have not put it to YouTube. So once I put it to YouTube, I will from next class onwards I will put it in the chat box itself.
okay, sir.
Okay, yeah, yeah.
And sir, is there any WhatsApp group or something for
No. I
PMRF?
mean, for PMRF, for us we don't have any WhatsApp group. you will have a discussion forum in the NPTEL course, in the NPTEL course page. If you want, if you have any questions to us, you can use that.
Okay, sir. Thank you.
Yeah.
Sir,
Yeah.
good afternoon, sir.
Yeah.
The assignment questions will be in descriptive form, sir.
Assignment questions for the first assignment, I just looked at the first assignment. It is completely MCQ, I think, multiple choice questions.
So is there any minimum marks concept like that, sir?
Minimum marks, I'm not sure. You can ask the course TA about this. I think the minimum marks will be, there will be no negative marking, I guess. So if you answer it wrong, you will get 0, else you will get the full marks.
Okay, sir. Thank you. Thank you.
Yeah. Okay, so I'll close the call, and we'll meet again next Saturday 4 to 5. You can join by the same link. Okay, thank you.
Thank you, sir.
Yeah,
Thank you, sir.
Thanks.
Thank you.
Thank you, sir.
sure.
Thank
Yeah, bye.
you. Bye.